Good evening, sir.
Good evening, good evening.
Good evening, sir.
Good evening, Pratyay. Good evening, Vaishnavi.
Good evening, sir.
So hello everyone, good evening. So whoever has joined, so we can start. So I'm sharing my screen and the question. So you can start attempting it. Is the screen visible?
Yes, sir.
Okay, so please try to attempt it, then we'll be starting discussing it.
So is it single correct or multi correct?
Single correct. Niche A. Anish, here it is asking which of the following cannot be found.
Oh, yes.
Okay, no. Rahul Prajapati got C. Rahul, can you explain how you got C?
So I misunderstood the question, sir. Sorry.
Okay, fine. Okay, one more minute, then I will start discussing it.
So then it will be A.
Will not be product. A will be product, no? A is direct, you can see. Okay, 1 minute. In A, there will be OH. Okay, in the A option. They will not be, so there is a slight modification in A option. Instead of bromine, it will be OH there. Okay, Rishi, can you tell how you have done?
So basically, I basically broke the double bonds and formed the options. And the D option, we get that outside the 5-membered ring, there are 4 carbons, which is not possible.
So by objective approach you have done. Mechanism you have not done by proper mechanism.
So, but I mean, there are so many products that we have to see the product and then decide the mechanism. No?
So, okay, you see the product. So tell me something about mechanism, whatever you can say.
Sir, basically, okay, in option B, I broke the pi bond that basically Br leaves.
Br leaves, then what will form a Br leaves? It is protic solvent.
Carbocation.
Carbocation,
And
okay.
that pi bond breaks, so that negative charge will go to the top carbon and it will form a pi bond there.
Resonance will happen. So pi single positive charge is there. So delocalization will happen.
Yes, sir. And the same thing for the opposite side, and we can get a positive, negative at the bottom, which will form another pi bond. So that way we can get option B. C, like that we can get option B.
Okay, fine, very good. Okay, so let me ask from Samarth. Okay, fine. Okay, so I'm discussing this one. So major part has been already told by Rishi. So by mechanism, if we go, so here you can see you are having protic solvent.
So this will go in SN1 reaction, right? Ag is there.
Yes, Ag is there, protic solvent is there. So SN1 reaction, carbocation will be formed. Then what you have to do, the first product A, that is very easy. Just carbocation will form, and in the carbon where carbon is there, OH will attach. So you'll be getting A product. Okay, so by mistake I have written there bromine. It will be OH there. So let me discuss the mechanism. So in the presence of water, Ag plus will take away this bromine. So you are getting AgBr plus you will get one carbocation. So this carbocation will be like this one. And here CH2, CH3. So one product you will get from here like H2O. So oxygen lone pair will be getting attached to this carbocation. So oxygen will have positive charge. So to neutralize that positive charge, hydrogen will leave. Okay, so H2O will attach, hydrogen will leave, and at the end you are getting OH attached to the whole compound. Directly I have written H2O minus H plus. So here OH will attach, and here you are getting CH2, CH3. So this is your A option. Now this you can see like positive charge, single bond, double bond. So there is conjugation, and whenever conjugation is there, you can draw resonating structure. So this pi bond will shift here, and you will get positive charge at this position. So here you got positive charge, and here you are having CH2. Here double bond, CH2, CH3. Now here again in this carbocation, what can happen? Oxygen can give lone pair, and then oxygen will have positive charge, hydrogen will leave. So basically OH will attach at the place of carbocation. So you got here OH, CH2, CH2, CH3, and here double bond. So this option you can see it is option B. Now here again you can see positive charge is again in conjugation with pi bond. So again this pi bond will shift here. You get another resonating structure. Carbocation shifted to this position, and here you are having, now again OH will attach like the previous mechanism. This. Now you can see this one is option C. So this you got option C. So all the three options you are getting A, B, C, but D you will not be getting. So D, you can see if you see the option, the carbon which OH is present, their carbocation cannot go because on that carbon atom conjugation is not present. By any means, by any conjugation, the carbocation cannot go there. It can only go here. So we have drawn that structure. By again resonance gone here, here. So we drawn a structure, but it will not be going at that carbon. So is this clear to everyone? Any doubt in this?
Sir, is the extra methyl also like a thing, or is that a mistake?
In which
So in the
structure?
option D, they've added like one more methyl instead of the bromine.
In any way, if I make it bromine also, then also it will not be formed.
Yes.
Okay. So main purpose of giving this D option was that carbocation will not go at the carbon where OH is there. Okay. Here, if I keep methyl or bromine also, if I keep, then also it will not be formed. Okay. So next question we can do. Okay, do this one. So this is match the following type question.
So what is crown ether?
You do by according to your knowledge, then I will be explaining.
So on the C option, what is above the arrow?
KF.
KF. Okay. Thank you, sir.
KF and below arrow crown ether DMF. Potassium fluoride in option C.
So can it match to multiple?
Okay, so it is only single it will be linked. Means A will be linked to only one of the PQRS.
Yes.
Okay, so this I should not tell. Means in exam anything can come. But okay, I'm telling this one. Okay, one more minute, then I will start discussing. Okay. Okay, so we will tell SQRP Rahul Naveen. SQ. Okay, Rahul Naveen, you explain how you have done. Rahul, can you hear me? Rahul Naveen. Okay, Rahul Prajapati, you explain.
So for
Hmm.
B, I got Q because it's on second degree carbon. So can easily like SN2 can be happen.
For B.
So and yeah, for
Okay,
B I got Q.
but there is protein solvent, no? CH3, CH2OH. Hmm? If I'm taking CH3, CH2OH, So it should be SN1 or SN2. Okay, tell for other options.
And
Hmm.
and for C1, I thought like it won't be possible, sir, because fluorine is there. So fluorine is not a good nucleophile in polar aprotic solvent.
Polar, yeah, very good. F minus is not because polar aprotic. But
Sorry,
in
sir, polar protic,
in polar protic solvation happens, no? So fluorine is not good nucleophile. But here I've taken DMF. Then what issue? In DMF, F minus can work. There is no solvation. Okay, tell for other.
And so D will go by SN1. So in this rearrangement will happen. So the plus charge will go to the there it is most stable. So D I got P, and other one I don't.
Okay, fine. So let me ask now. Okay, Vaishnavi, you tell.
Sir, same thing.
Same thing. For
Yeah,
A, for A, you have done A.
Yeah, A I wrote as S because it's already on tertiary carbo. I mean, it's already a tertiary carbocation.
So it means OCS3 will remove and OH will attach or Br will attach. If you are telling that it is racemization.
BR.
Br will attach. Okay.
Because CH3OH will split as OCH3 minus and H plus.
Okay. So you thought OCS3 will not replace OCH3, so it's better
Yeah.
Br should replace OCH3. Okay, very good. Okay, then Nishant, you tell your logic.
So for which one?
For A, same like Vaishnavi told.
Same logic only, sir.
And for BCD, anything else from Rahul?
For B, I got SN1. So
So SN1 S nearly racemization without rearrangement. Okay, and for C?
and for C, I got SN2.
For C, you got SN2. SN2 why?
It's a 1 degree carbon, and it's in the KFF is a strong nucleophile, and the solvent also is aprotic.
But here we have taken KF, no? KF is ionic or covalent.
Ionic. So F
And
minus.
and DMF is ionic or covalent.
DMF? I don't know.
DMF. DMF will be what? Covalent, or it will be covalent, no? Solvents are covalent only. They are being covalent.
Yeah.
So you know that like dissolves like.
Yes.
So KF will be dissolved in DMF or not?
It will not be, sir.
So if it is not dissolving, then how it can react as nucleophile?
So what about crown ether? Can it dissolve it?
So there will be something role associated with crown ether. Okay, so that I will explain that what it is doing. So that it is making KF dissolve in DMF. Okay, that you told, right, that F minus can behave as nucleophile because here it is not taken protic solvent, but it has to be dissolved. No? KF is ionic, DMF is covalent. So how covalent is dissolving in ionic, that we have to see. That is the role of crown ether. And D option already told, that is right, that Rahul told. Okay, Arjun Sahai, can you hear me? Arjun Sahai? Okay.
You hear me?
Yeah.
Sir, my mic wasn't working, sir.
Okay, fine, no issue. Okay, so I'm explaining it one by one. So first taking option A. So in option A, what is we have taken? CH2, CH3, whole thrice carbon, OCH3. and then we have taken NaBrCH3OH. See what happens, like if you give substitution reaction, you will be getting CH3O minus, and CH3O minus is very good base because negative charge is very unstable. It will react very fast. The one which are very good base are bad leaving group. Because leaving group are those in which negative charge should be stable, then only they will leave. But it is very good base. Suppose it once leave, negative charge formed, it again start reacting very fast because it is very good base. So that's why it is bad leaving group. So first of all, this you should know that very good base, if there is, that will be very bad leaving group. So this OCH3 will not go outside. And then directly you can say carbon oxygen bond is very strong and stable. Very strong and stable. So since carbon oxygen bond is very strong and stable, by taking nucleophile of low power, that will not work. Because suppose here you can say like Vaishnavi told, CH3O minus I will be getting and Br minus I will be getting. So CH3O minus will not replace itself. Br minus we can consider. So Br minus is not very good nucleophile. Okay, it is not having very high power so that it can replace CH3O minus. Because first of all, it will not be able to break carbon oxygen bond. And at the same time, it is very bad leaving group. So its nucleophilicity is not enough to make OCH3 come outside. So can you suggest what are the ways through which we can make this OCH3 come out? What we can do to this oxygen atom so that it has to mandatorily come out? Can you tell any mechanism? See what we can do here. If suppose we are taking acids like HI, HBr, so they will be quickly giving H plus. Okay. Now what will happen? This oxygen lone pair, after seeing H plus, this lone pair will be donated to H plus. So suppose if I take this example only, so you will be getting CH2, CH3 whole thrice carbon O CH3. So in presence of, if I'm taking HI, so there will be like presence of H plus. So this lone pair will be given to H plus. And what you will be getting? You will be getting OCH3 plus. CH2, CH3 whole thrice, carbon, OCH3 and plus. Now, hydrogen will be also there. Now, since oxygen is having positive charge, so this positive charge, oxygen wants to remove. So now it will try to break the oxygen-carbon bond very easily. Now this CH3O group can be removed. Then you will get carbocation. Then you can make any nucleophile to attack. Understood? So everything is right in this reaction, but you only need activation of this oxygen atom so that it can come out. And that activation can be done like you bring positive charge to it. For that purpose, you need H plus. And H plus should be given by some good acid. So HI, HBr you can take. H plus will be given easily. That OH plus will be formed. Then CH3O can come out at CH3OH. Carbocation will be formed. 3-degree carbocation will be very stable. Br minus can be attached. Since there is no HI, HBr present, that's why this reaction cannot happen. So that's why for A option, this will be R.
So what if we change solvent
Which solvent do you want to take?
like polar protic?
So CH3OH is also polar protic.
No, aprotic if we aprotic.
Or protic. But that will means then that will not give you SN1 reaction. No? You need SN1 also, no? Because there is 3-degree carbon.
Okay, fine.
Okay, so changing the solvent will not serve the. Okay, so
Sir, in the solvent, The CH3OH will become CH3O minus and H plus. Then the H
Means
plus can protonate the OCH3, right?
yes. Means if you're taking acid HiHBr,
No, even in this one, the CH3OH is a
this is not good acid. This will not work. Means of course technically you can say H plus is coming out, but CH3OH is not good acid.
yes, sir.
Okay, and it is acting like a solvent, so you need some good acid so that H plus can be given. Then only it can work.
Yes.
Okay.
So can we also
Can't
use the
oxygen
logic?
Yeah. Ask.
can't oxygen give lone pair to Na plus? Is that possible?
So what that will serve? Means then
Instead of H.
ONA will form the ionic bond, no? Metal
Yeah.
and non-metal.
So then plus charge. Oh.
No. So in positive charge will not come. Means ionic bond you are forming, then lone pair. See, lone pair not used for this type of bond. Then you have two bond with Na, then plus charge. It never forms like that one.
Okay.
Okay. O minus Na plus can form. O plus Na plus that will not work. No? Any more one person more was telling.
So
What
I
you
use
are
the
saying.
logic that if
Mhm.
we have to take out the OCH3, we have to obviously form HOCH3, and that's already present in the it's solvent itself. So it will drive the backward reaction. So the
No,
reaction won't happen.
yeah, so means you are telling leach earlier, no? So we will be having some mechanism so that we can decrease the concentration of CH3OH.
Yes, sir. So,
Then
but
it
is
will be
that
okay.
logic
Na?
fine, or do we just have to use the weak? Like,
What? Repeat again what
so
you are telling.
is the logic fine if I say that since it's
Hmm.
already Le Chatelier principle basically for this
So
question?
yeah. Your question is very valid. That again CH3OH is forming, so concentration will be of product will be rising. So the reaction proceed backward. So what we can do, we can have some mechanism through which we can decrease the concentration of CH3OH. Then it will work.
Okay, sir. Yes.
So I have a doubt.
Yeah, ask.
Sir, when that like O plus is formed, why won't the hydrogen leave again? Like, is it because the CO bond is steric?
No. See, when positive charge is formed, so the bond will be broken down. That will give some good, stable product. So tertiary carbon you are getting that is more stable. No? So why would hydrogen will leave as positive charge?
So, but the CO bond is like very strong.
CO is strong when there was no positive charge. In neutral CO you are talking about. Now your oxygen is having positive, so it became weak now.
Yes.
Because charge structure are very means they want to decrease charge. Now they will not think about carbon oxygen bond. They want to decrease charge. They are ready to break carbon oxygen bond, and by breaking carbon oxygen bond you will get 3-degree carbocation. That's why carbon oxygen bond will break.
Yes.
Okay. For B, so B was easy. So here I have taken protic solvent. So a protic solvent I have taken and it is like 2 degree. So 2 degree can manage to give SN1. The protic solvent is there, but you can see there is no need for rearrangement. So 2 degree carbon will form. If it rearranges also, then also 2 degree is forming, and 1 degree it will not rearrange. So it will give racemization, nearly racemization, inversion greater than retention without rearrangement. So for B, S is the appropriate one. Now for C. For C, good points we have discussed. The first point came out like that one, that F minus is poor leaving group, poor nucleophile in protic due to solvation. Because F minus is having very smaller size, solvation will be done by water. So F minus cannot move, it will be like poor nucleophile. But here I have taken DMF, that is aprotic. So F minus is good nucleophile in aprotic. Okay, so this is working fine, that F minus can work in DMF. But now the second point came here, that KF is ionic and DMF taken is covalent. So Like dissolves like. So Kf is not soluble in DMF. So here comes the role of crown ether. So what happens, like crown ether is having like cavity type structure. If I draw its structure, it is like that one. Like this one. This is crown ether, one of the crown ether example I've taken. So it is having cavity like structure. So in between the structure there is some space, and here K plus can fit very easily. So what has happened, like your K plus is locked inside this ether, and ether, since it is having like hydrophobic character, or you can say it is like covalent character, due to this property of crown ether, Kf will be now soluble in DMF. So this property that I told, it is known as phase transfer catalyst. So here crown ether is phase transfer catalyst. Phase transfer catalyst, I mean to say, if there are two immiscible liquids which are not soluble in each other, crown ether will make one liquid to be soluble in another. So that's why it is known as phase transfer catalyst, and it is doing by this method that it locks the cation, giving the like you can say covalent character to it, and then it is soluble in DMF. And at the second advantage is like that one, since the cations are locked, your F minus is roaming very freely. It is soluble also, Kf now soluble also due to crown ether. K plus are locked, the cations are not disturbing. Anions, you can say anions are naked, unprotected, naked, like that you can say for anions. They are moving very freely, and their reactivity became very high. So this point also you can write F minus are moving freely. They are naked. So that's why F minus reactivity increases. Okay, so in this way, due to crown ether, F minus, it is possible that F minus is giving you SN2. So for C, it will be like QSN2, because you can see it is 1 degree halide, so no problem of steric hindrance. Any doubt in this?
So does it break the bond between potassium and fluoride ion?
See, yes. See, in presence of crown ether, when the K plus C the cavity according to its size, automatically due to like charge development, K plus and F minus will form, and K plus quickly gets inside this crown ether.
What drives it to go inside?
Stability means you can say like this one, like when we discuss solvation of hydration. So there also cations are solvated by H2O. So that is like some release of energy. The same thing is happening here also. It is not like entire solvation. Already cavity is made, just you have to insert inside it. So K plus will become more stable. So there will be like some release of energy, you can say.
Yes.
It is a driving force.
Yes, sir.
Any more doubt? Okay, so now D1. See, D1, here it is easy because the bromine, which is the carbon to which bromine is attached, it is not bridgehead carbon. So that's why it is normal carbon. So bromine will remove from here, protic solvent taken. So it will be SN1. Carbotine will form. To bridgehead, it will not rearrange, but it will rearrange to this carbon atom where two methyls are there, and 1,2 methyl shift will happen. So for D, we can draw. So in presence of H2, what will happen? carbocation will form. So here carbocation forms. Now with 1,2 methyl shift, methyl will shift here, carbocation will shift here. So this carbocation is actually formed 3 degree. So that's why it is more stable. So SN1 will happen and rearrangement will also happen. So P option is good for this one. So for this we are having P, rearrangement will happen. And for A I also told you that is R. And for this I also told you Q. So this question we have done. Any doubt? Please tell. Okay, then solve next one. Okay, solve this one. This is also match the column.
So if it says catalyzed by polar aprotic solvent, does that mean that in this reaction only there's a polar aprotic solvent, or if we if we put it in a polar aprotic solvent, then it will be catalyzed?
So it is like that in any of the reaction, it is not given regarding solvent. So no solvent is given. So you can apply this option that if I take aprotic solvent, then it will enhance the reaction. And if I take protic solvent, it will harm the reaction. In this way, you have to take this statement. And here also one will be having only one. Okay, like A will be having only one of PQRS. C option, here you can see the bromine will be at bridgehead carbon in C option. Hmm. Okay, so we will explain. Rishi, you explain?
So the first one I didn't know, but from the second one,
Hmm.
PR will leave. It will be a benzylic, so
Hmm.
it'll be more stable. So then it won't rearrange.
Rearrange. Okay,
And then
fine.
it's EPS, so it's SN1.
Hmm.
Then C, it's Bread's rule. It can't form a carbocation there,
Hmm.
so it won't react.
Okay, and then
And then
D.
the last one, it's 1 degree and an OH minus nucleophile. So if you put it, and it'll take place through SN2 because it's 1 degree. So if you put it in PAS, then it'll be catalyzed.
But already we have taken water, no, here. So water means which reaction?
So sorry, sir, I messed up the options. So BR will leave. That will get a positive charge. That will shift and to 3 degree,
Hmm.
and then it will the carbocation will be 3 degree, and then OH will come. Methyl shift will take place.
Yeah, very good. Okay, what you can say for A?
Sir, I'm not sure about it.
So
Sir,
tell me what.
Sir,
tell
एक
me.
OH is a strong base.
Yeah, OH minus will form. Then
Strong base meaning like it's more likely to go under SN2.
but that will depend upon solvent also, no?
Then
Means I have not taken aqueous KOH or alcoholic KOH.
oh
So both way you can think of which should be good here. If you want to see, is there any possibility of SN1? Is there any 3 degree benzyl something that is going to be formed?
No, sir.
So which reaction will be good here? SN1 or SN2?
SN2.
SN2. So for SN2, you need which solvent?
Aprotic.
Aprotic. So one way of thinking like this one, but now you will be having doubts of why, like if you are telling polar aprotic will be benefiting it, so how polar protic is harming it? So you are having this doubt?
the protic will balance out the S also, it will interact with, so the OH won't be able to.
Partially you are right. OH will not be able to do its work, but why?
Because
Due to sulfur.
sulfur aprotic will stabilize both charges plus and minus. So the protic solvent will come around H, the negative ion. It's around the S plus sulfur it will surround.
No, 1 minute. If I'm taking any protic solvent, suppose if I take water. So in water, which is the entity used to surround?
OH will surround OH minus.
OH minus. OH minus will surround positive charged. You mean to say?
Yeah.
Okay. And the positive charge, positive charge will surround. Negative charge will surround positive charge, and positive charge can also surround.
Yeah. So the positive charge will start surrounding this other nucleophile. So it won't be able to react.
So this one logic is good, I think, because here the main reacting species will be nucleophile.
Yeah.
So someone is surrounding nucleophile that will
so
retard your
nucleophile. Yeah, it won't have to go only.
Yeah, and like you told it, the negative will surround S plus, because that is also not possible because S plus is there, but it is very strictly crowded. So surrounding it will be very difficult. Okay, so OH minus will be surrounded by positively charged that can work here. Okay, so let me explain this one. So some part already told by Avnish. So what is happening, like if I draw this structure, so you are having S plus CS3, CS3, then CS3, then you are having KOH. So this will give, KOH is very good base, so it will be giving OH minus. Now what is happening, like this OH minus can also take out this hydrogen of CH3. This is alpha hydrogen, and whenever good base is present, it can take out the alpha hydrogen. Okay, so if it is taking out, suppose it is CH2 written and this is hydrogen, so this can take out this hydrogen. So there will be like numerous of H plus will be present if it is taking out like this one. So what this H plus will do, they will surround OH minus, due to which nucleophilicity, if I talk about, nucleophilicity OH minus will reduce. Okay, so if you are giving polar protic solvent, the same work will be enhanced more, so that will be decreasing your nucleophilicity of OH minus by more extent. So the reaction won't happen, and we want here SN2 be happen, because what happens, like if you are putting this reaction to SN2, so positive charge is there, so this sulfur will try to remove its positive charge. So how it can do, this OH minus will hit on this carbon atom, and this bond will give to sulfur. So what you are getting CH3OH plus sulfur CH3 whole twice. So as CH3 whole twice is very good nucleophile. Okay, so here no carbocation is formed, just OH minus reacted in one step, and this SCH3 whole twice gone outside, and you got SN2 reaction. So for that purpose, KOH is there, and you need SN2. So taking polar aprotic solvent is the good idea. So polar aprotic will enhance rate of reaction. Any doubt in this?
So
Hmm.
I did it in a different methods. First part, yeah, sulfur S plus is a good leaving group, so I did that. Then I considered it if the sulfur CS bonds would be weaker, so then you'd get methyl group. So then for the methyl group, SN2 is more probable. No, that's why.
So same thing you are telling, whatever I have done. Means CS3 is 1 degree, so OH minus nucleophile can attack better through SN2. That is only you are telling.
Yeah.
So same way, the same thing I have done.
Okay.
Okay. So that's why SN2 required here. So that's why polar aprotic is beneficial. And another logic I have given you, if you are taking protic, so that will retard the movement of nucleophile by doing solvation of it. Now other three options are very easy. Okay. So B, like Rishi told, if bromine is removed, you are getting a stable carbocation, and you have also taken here protic solvent. So both are giving hint for SN1. And since benzylic position carbocation is formed, so that is having very high stability. So there is no need for rearrangement. So for first one, let me write. For first one, it is P. For B, what is stable carbocation will form? So this is very stable. So SN1 will happen, and there is no rearrangement required. So second will be R. Now third one, Brett's rule applied. So formation of carbocation is very difficult. So SN1 will not happen, or you can say very little chance of reaction. So this will be S. For C, you can write Brett's rule. And for D, see here, protic solvent is taken, so SN1, H2O, polar protic solvent, so it will be SN1. And you can see here, by rearrangement, it can give you 3-degree carbocation. So therefore, rearrangement will happen here, and you will be getting 3-degree carbocation. So first bromine will leave and you get this. Then 1, 2 methyl shift. Carbocation will rearrange and then OH will attach to give you the product. So any doubt in these four? So first was only tough, the other three were very easy. Okay, do this one. So you can take here PPS, polar protic solvent.
So if they had not specified the solvent, we'd have to take both the cases, right? SN2 and SN1.
So if you take both, then it will become complex.
So,
okay, then do that way.
Oh.
In that way you can explain.
So we assume there's no solvent, or in this question PPS is given.
Yeah, like he told Prathai, he is considering both. Okay. So if you are not taking PPS, then also you can do by considering both.
Yes.
Okay. Okay, so let me remove this one. You first try with both. Okay. Okay, who will explain? Gohan, can you hear me?
Yes, sir.
Explain.
Sir, I was a little. One second, sir. 1 second, sir.
Khushi, can you hear me?
Yes, sir.
Explain.
Sir, if it's polar protic solvent, then SN1 will be favored. So it'll be D option. I mean, S will be a little more, but we can say it'll be 50-50. If it's polar aprotic, it'll be C because 100% inversion. And if it's both cases, if we're considering, it'll be B because there will be more S because of the SN2 reaction, and there'll be R because of the SN1 reaction.
So both you're considering. So it cannot be 100% because some part is SN1 is happening, and it should not be 50-50 also. So it should be 60-40. That only you want to say?
Yes, sir.
Okay, fine. Thank you. Okay, Rishi, you explain. Any other view?
Same, sir.
So in exam, what you will mark? BC or B?
So I would mark B. So because the SN1 will give both 50-50 approximately, and SN2 will give only S. So there will be more consideration of S compared to R.
Yeah, and 100% S we cannot say because some SN1 is also happening. It is not entirely SN2.
Yes.
Okay, very good.
So both as in, are you adding like half of polar protic, half of aprotic? What do you mean both?
See, if according to question, I'm telling that question is coming in multiple choice option and it is not stating solvent. So by default, you have to consider both the solvent, not 50-50%, one at a time. Means if you are mixing protic with aprotic, it will consider protic. No, means you cannot say like it is 50-50%. Either you can take one protic at a time, either you can take one aprotic at a time. Here I am considering both cases.
Oh, separately.
Yes, separately, and then I'm looking for product ratio. Means product ratio I can combine. No, products I can combine. Once I've done SN1 also, SN2 also, then I am matching with reactant. That reactant, there was this 100 molecule R. Out of 100 molecule, I got 60 molecule S and 40 molecule R. That I can do, no?
Yes.
Understood? So in this way. Okay. So let me explain. So like if that solvent is not stated, so you have to consider both. So since it is 2 degree, you already know 2 degree are giving both SN1 also, SN2 also. So compound here is taken R, here carbon, it is Cl, and here R dash. So 2 degree it is, and it is R given. So it can proceed via SN1 also, it can proceed via SN2 also. If it is going through SN1, so we already know it is not 50-50. Inversion is somewhat bigger. And I also told in class, like whenever you are having option, both option 50-50 also, another option with inversion more than retention, then you have to go with that one, inversion greater than retention. Then you do not have to go with 50-50. So here, if your SN1 is happening, so your less than 50% will be the product of retention one. And if it is greater than 50%, then it is inversion. Or you can say for inversion, it will be greater than 50%. For retention, it is less than 50%. And if you are going with SN2, so it will be 100% inversion. Okay, so that's why if you are seeing both SN1 and SN2, so you are getting R also, you are getting S also, because there will be retention also, there will be inversion also, because SN1 will give you some part of retention also, and the rest inversion you will be getting from some part from SN1 and some part from SN2. But since inversion is higher, here also greater than 50%, here also going towards 100%, your S will be higher in quantity than R. So that's why there is only one option, B option, 60% S, 40% R. So that's why B will be the correct answer. Okay. Okay, do the next one. Okay, do this one. Rahul, you are wrong. Do it again correctly. Mayank has written the previous one. Avnish has written D. Avnish, can you explain how you got D?
Yes, sir. So ratio management is my 50-50. Then inversion product also can happen.
Yeah, out of 70%, half will be.
So both SN1, SN2 will take no.
No, here solvent is given, no CH3OH.
Oh. Then also see 70% HMIs. That means 35-35 will be both front and back. And then the other percent that will come from backside. So be inversion. So the inversion is how much? 30% is inversion.
So total you have to do, no?
Yeah, so 30 plus 70 by 2.
65.
That's 65. A calculation wrong. So A it will.
Just let me ask from somebody else. You are not telling any answer. Ayan, can you hear me? Ayan Tripathi?
Yes, sir.
Can you explain?
Yes, sir. So firstly, it's given 70% rationalization, so you don't have to really think of anything, Wesley. So 70% is obviously SN1 attack, so 50-50. The remaining 30% is SN2, so 100% inversion. So from that, we have 30% completely inverted plus half of 70, which is 35. 30 plus 35, 65. So option A should be correct.
You told right, but here do not use SN2 term. Okay, you mean to say that it's backside attack or inversion?
Yes, sir.
Okay, fine. So you have told right. So let me explain. So here, backside attack, if we are talking about, so through that we mean inversion. Okay. Now, since it is given here, or by default, I am considering that initial one is R. I'm assuming, okay, because entirely we have to do in percentage. So it is upon me that I can assume the initial one. So initial one, I'm assuming that it is R. So reactant it is 100% R, and that is your reactant. Now, according to question, if it is given 70% racemization, so 70% of this 100% gone for racemization. Since it is SN1 reaction, so the remaining 30% will be inversion, because we know inversion is greater than retention. So if 30% are not racemized, so they will be contributing to inversion. So 30% will going to inversion. Okay. Now this 70%, it is like 70% total R plus S, because racemic mixture is always composed of both R and S. So here, if I further break it down, so 35% I will get R, 35% I will get S. And from inversion here, if I have assumed the initial reactant to be R, the inversion one will be entirely S, but it will be only limited to 30%. So here you are getting 30% S. Now, if I want to find, like question is asking for percentage of backside attack. So backside attack is the inversion one. So question is asking for percentage inversion. So that will be like percentage backside product. So what you have to do, just you have to club this both inversion one, so that you are getting 35 from racemic, 35 from racemic you are getting, and 30% you are getting from inversion product. So total you will be getting 65%. Any doubt in this? Okay, do this one. This question is based on Grignard reagent. So there is one more option, D option. First look for these three that I will show you, D option. And this is a multiple choice question.
So could you show the D option?
So could you go back also?
Sir, could you show D?
A, B, C, D. All of you are getting A, B, C, D. Okay, so I'm discussing. Okay, we are not having much time. Anyone want to explain? Charumati, can you hear me? Charumati Sitaraman.
Yes, sir.
Can you explain how you have done this?
Sir, I'm not very sure.
Hmm?
I'm not sure.
Yeah, tell whatever you know. So I will correct it. Grignard region, what does Grignard region do? Which nucleophile it provide? Hmm? Tell. Okay, I'm explaining. See here, what happens like in Grignard region in class, it is told to you that RMGX. So this will provide R minus, and that will be acting as base as well as nucleophile. And if carbonyl compound reaction is taken with carbonyl compound, so alcohol is formed. For example, if I take A option, so A you are having this, and this you are reacting with CH3 C double bond O CH3, CH3 C double bond O CH3. So this will give you nucleophile or base, this one, R minus. So whatever the carbon magnesium bond is there, you have to break that down, and carbon will be a negative charge. Now this can behave as base also, this can behave as nucleophile also. Since here I cannot see any acid which can give H, so means any acid like which can release H plus ion for this base. So it cannot behave like base, it will be behaving like nucleophile. So this negative charge will attack on this acetone, and this pi bond will shift on.
So will this be a nucleophilic addition reaction?
Yes, it will be nucleophilic addition reaction. So here this will attach on this carbon CH3, and this will become O minus, and then you have also taken H plus. that H plus will be coming from solvent, and this O minus will accept H plus from solvent. So you are getting this 3-degree alcohol. Okay, so this first statement is right. Okay, now if I look for second one, what is happening? So first step taken Mg ether. So whenever we are taking Mg ether, so that is formation of Grignard reagent. Magnesium will insert between carbon and bromine. So first this Grignard reagent is formed. Then this Grignard reagent will give the base or nucleophile. This and this. Here negative charge. Now what is happening here? See, I told it can behave like base as well as nucleophile also. So what is happening? The products which are listed here, they are corresponding to major product. And if your Grignard reagent is giving base, it is getting chance to behave like base. Your product of base will be the major one. And here you can see like hydrogen is attached to electronegative atom. So whenever hydrogen is attached to En atom, higher electronegative atom, this hydrogen can be accepted by this R minus, and this R minus can behave like as a base. So the first reaction which it will be giving, that will be more favorable for major product. This negative charge will accept this hydrogen of nitrogen. So you get like this one here, hydrogen is attached. So that's why B option is not correct. B option will be correct when it is not getting chance that it can accept hydrogen from any electronegative atom. But since here you can see electronegative atom is present, so through that it can accept H plus. And again, since water is taken in high quantity, so this N minus can accept H plus from water itself. So final product that will be present in a large quantity will be this one, not this one. So this product is formed when you are attacking with phenol CHO, like the previous option, nucleophilic addition reaction. But here, since base reaction can be given, that's why this is not the correct. Now in C option epoxide is taken. So this reaction also done in class. So epoxide, what happens? So first of all, pH MgBr will give you pH minus, and here again there is no chance to act as a base because no hydrogen attached to electronegative atom. So only it can act as like nucleophile. So then you have taken this epoxide. So it is highly strained condition, epoxide. So what will happen? This will attack here at carbon, and this will shift on oxygen. So you are getting this one, like this one. Now again there is H plus ion present. So this will be your final product. And this is given also. So option C is the correct one. Now in the D is easy, just nucleophilic addition reaction. So for option D, you will be getting pH minus. Here no hydrogen attached to electronegative atom, so no function of base, only function of nucleophile. So nucleophilic addition will be happening. This will attack here. O minus will be formed. pH C, here hydrogen, here O minus. Then again H plus is present. H plus will be accepted, and you will get 1 degree alcohol. So aldehyde give 1 degree alcohol. So this is also right. So correct answer is A, C, D. B will be not, due to acid base reaction. Okay, solve this one. D. Yes, D will be the correct one. Okay, let us do then weekend. Yeah, D cannot be prepared, ABC can be prepared. I've taken that only. Okay, 2 more minutes, then I will start explaining. Okay, who will explain this? This is very easy. Gagan, you have done right.
Yes.
Nityanth, can you hear me, Nityanth? Nityanth is not there, I think. Archit, can you hear me?
Yes, sir.
Can you tell how you have done?
So basically, it should be ABC as it is written that it can be prepared as an acid radical. It is the formula is ROCl, as I believe.
RC-1-OCl, yes. Then
so we can for the Grignard reagent, it should be the same the same alkyl group should be used, but in D, it's not.
So you mean to say whatever R you are taking for COCl, that same R you have to take in Renard also?
No, sir. What I meant to say for A, I took CH3OCl for the acid chloride.
Okay, CH3Cl, yeah. Then Renard, for Renard you have taken?
For Grignard, I had taken PHMG. I mean, yeah, PHMG.
PHMGX. Okay. Okay.
For
So
B, I had taken CH3OCl for the acid additive for the acid chloride.
CH3C-Cl.
Sir?
CH3C-Cl you have taken acid chloride for B option.
No, for B option, acid chloride as PHOCl.
Okay, PHCOCl. And Grignard agent CH3MGX.
Yes, sir.
And for C option?
Similarly, for C option, CH3OCl as acid chloride and ETMGBr as the Grignard reagent.
Okay, then for D?
D option, I couldn't get it. So, and I
Okay,
believe
can you tell the logic that why you are on what basis you are taking Grignard reagent, that R group? Means why you have taken based on your answer, the one group which is repeated more than one, that you have taken Grignard reagent.
So it is written excess of Grignard reagent.
Okay. So what do you mean by that one? How that is related to your answer? Explain me that one.
So sir, if only Grignard reagent is used, then we have to use it once. But it is written excess, so I had used it twice.
So okay, what do you want to say? Since excess of Grignard reagent is taken, so every time Grignard reagent is reacting, since it is in excess, the R group will be reacting multiple times.
Yes, sir.
Okay, so the R group which you want to repeat, that you can take in Grignard reagent, because that will be in excess. That will come more than one time through excess Grignard reagent. You cannot take that in R serial mono-Cl. And in option D, the reason why you're not getting, because all the three R groups are different. So if R group is not repeated for more than one time, so you cannot take it from Grignard reagent. So you have to take two types of Grignard reagent in multiple steps. Then only two different R group can come. And that you cannot do. You can take only one type of Grignard reagent. That's why D option cannot be found by this way. Okay, so let me explain. Okay, so your solution was right. Okay, so let me explain. So like what he told, so option B I am taking for explanation. So for in option B, you want to form pH, CS3, and here OH. Okay. So what Archit told, like he has taken pH, C double bond Cl, and then he has taken CS3 MgBr. So what is happening if you are taking like this one? So first step is like addition elimination. So from here you will be getting CS3 minus. So this negative charge will attack on this one. This will become PHCO minus. Here CS3, here Cl, and this negative charge will again become pi bond, and this chlorine will leave. So finally you are getting pH C double bond O CS3. So what I mean to say, this chlorine is replaced by CS3. So now you got two R group, phenyl and CS3. Now in the final product, you are having two CS3 and one phenyl. So one phenyl, one CS3 you already got, you need one more CS3. And that can again come by Grignard reagent only, because you have taken excess of Grignard reagent. You have not taken excess of phenol, PHC double bond. You have taken excess of Grignard reagent. So again, Grignard reagent you can take CS3 MgBr. Now again, here CS3 minus will attack on this one. So you get PHCO minus, here CS3, here CS3. And by accepting H plus, this will be giving you alcohol, where you are having two CS3 and one pH. So through this mechanism, we came to know the unit which is getting repeated, that has to be taken in Grignard reagent, and the unit which is standalone present, that can be taken as chloride, acid chloride. So that will be present from initial one. Now one more I can take for explanation. Suppose if I take C. So for C, you want to make 2 ethyl and 1 methyl. So here 2 ethyl, 1 methyl, and here OH. So the one which is not repeated, take it as acyl chloride, and the one which is repeated, you take it as excess Grignard reagent. So ET, Mg, Br. So one time it react, this chlorine will be replaced by ET. You get CH3, C double bond O, ET. Now again, ET, Mg, Br, Grignard reagent. So this ET minus will again attack on this carbonyl bond and you get alcohol. So you got 2 ET, 1 CH3 and alcohol. So this way this product can be also formed. Likewise, A option, you are having 2 pH and 1 CH3. So pH, CH3 here, OH. So here the repeated unit that can come from Grignard reagent. So you can start with CH3, C double bond O Cl. One time you take Grignard reagent, pH, Mg, Br. So this chlorine will be replaced by pH. You get CH3, C double bond O, pH. Again, you take Grignard reagent, pH, Mg, Br. You get CH3. Here pH. Here alcohol will form and 1 pH will attach. So in this way, A is formed. Now, but in D option, what is happening? All the 3 units are different. CH3, pH, and ET. CH3, pH, and ethyl. So here, 3 different units cannot be taken. Means you can take one unit as acyl chloride, so that will be present. Then the other 2 units you cannot take to different Grignard reagent. You have to take only one Grignard reagent. Since there are 2 different groups, so 2 Grignard reagent cannot be taken. So excess Grignard reagent cannot be utilized here. That's why D option cannot be formed. D cannot be formed. So answer will be A, B, and C. Okay, so this was easy. Any doubt in this? Okay, solve this one. So you proceed by taking DU. So through DU, you will be getting some hint. And 6, you can see like hydrogen numbers are approximately around twice. So there will be no benzene ring.
How will there be benzene ring?
There will not be benzene ring. Means you are having like C6H5 type structure, no? When hydrogen atoms are comparable with carbon, then you will think of that benzene. But since the hydrogen numbers are around twice, so there will not be benzene ring. And through du also you'll be coming to know, because if benzene ring is present, du should be greater than 4. And here you will not get du greater than 4. I mean equal or greater than 4. And since oxygen atom is present, so there you have to think of any functional group with oxygen.
Sir, could you show the options?
So could you go to the previous slide? So could you show the options?
So through option, you actually get a hint that which group will be there. So you can frame the starting compound based on that line also. So through option, you can see cyclohexane is present. Cyclohexane will be there. In cyclohexane, you have to do some modification to get the starting compound.
Sir, could you go back to the question?
Okay, 3 more minutes, then I will start discussing. Those time is not left much.
1 second, can you show the options? Go back.
It is multiple choice. Okay. It is written also correct options. Anybody done? Yeah, BC is correct answer. Okay, who will explain this? Arjun Sahai, can you hear me?
Sir, can you hear me?
Yeah, I can hear you. Please explain how you have.
Yes, sir. So first, the product Q will be methyl cyclohexanol.
Very good.
Sir, and then when you react that with concentrated HCl, the OH will be replaced by Cl.
You get double bond here.
Yes, sir. Sir, and then when you react it with H3PO4, it will get dehydrated, so there'll be a double bond at the methyl position. And then
HBr peroxide, so you have taken anti-Marconi.
yes, sir. And then other side, it will be free rad first hydrogenation and then free radical.
Okay, fine. So yeah, Hoffman, yeah. Okay, so let me explain this quickly. Like he told, the Q will be like cyclohex. You are having OH functional group on cyclohexane. Okay, so cyclohexanol. So for that purpose, there has to be keto group in cyclohexane. That will be your C6H10O. So for that only, this entire reaction is possible. So you have to start with this product. So you will calculate du for this compound. You will get 2. So one du consumed in this ring, another du consumed in double bond O, double bond. Okay, so this is the combination only you can take. So if you want to react further with Grignard reagent, you can take like that one also, like C double bond C also you can take one ring and one C double bond C, but Grignard reagent will not react with that. So the meaningful will be this only. You take keto group along with this ring structure. So this is the starting one. Then Me, MgBr and water. So this will give you alcohol. In last question we have discussed this one. Okay. Now concentrated HCl. Okay, one CSC group will be also there of this MeMgBr. Now concentrated HCl, what it will do, it will replace this OH. So instead of OH, Cl will come. Now this you have taken H3PO4, so that is like dehydrating agent. You already know this. H3PO4, dehydrating agent. So this is what it will do. It will place double bond by removing adjacent carbon atom hydrogen. So you get this alkene here. Now when you are taking peroxide, so you get Hoffman product. So bromine is attached to this position, which is less substituted. And when you are taking this hydrogenation and Br2H nu, so first we will be doing hydrogenation. So this double bond will be reduced to alkane by hydrogen added. Then we have done bromination, Br2H nu. So bromination is highly selective that we have discussed in class multiple times. Its ratio is very much higher for 3-degree radical, that is 1600. So here you can see it is having 3-degree hydrogen. So for that, the 3-degree hydrogen will be removed as free radical, and with that free radical, bromine will be attached. Okay, so this I think I have done the whole. Yeah. So based on this, you can see B, U, and T. What is U? Okay, U is this one, and T is this one. So you can see U is this one and T is this one. Yeah, so option B is right. And S and U. So S was this one, concentrated HCl, and U is this one. So that is also correct. So you are getting B and C. Any doubt in this question? Okay, do this question, then we can wrap up. Okay, so I am discussing it. See what happens, like this energy profile is given. So you can see like here it is having more than one step. So it will be SN1. It cannot be SN2 because SN2 happens in only one step. So you cannot get more than one hump there. So option B and option C you can rule out. Option B and D, because option B and D are SN2. See in option C what happens, like if you go with the mechanism, when you are having this CS3 whole thrice carbon Br plus CH3 CH2OH. So 3 steps taken place here. First is like donation of this lone pair to this carbon atom and Br is removed. So lone pair of oxygen donated, bromine removed. So this is your first step. Second is like here oxygen will be having positive charge. No, sorry. This lone pair is going to be given this carbon atom, bromine is removed. So in second step, what is happened? Carbocation is formed. Okay. So bromine is removed, carbocation is formed. Then lone pair is given. You can write like this one. This is second step I will model. First is carbocation is formed. Carbocation is formed, bromine is left, carbocation is formed. Then to carbocation lone pair of oxygen is donated. Bromine, you can remove this one. Lone pair of oxygen is donated and O plus is formed. Okay, O plus is formed. Now in third step, what will happen? Deprotonation will happen to form OH or to remove positive charge of oxygen. So that's why 3 steps are happening here. So you will be getting 3 transition state that is relating to this one. Okay, so I'm telling one by one the transition state, and from that you can relate the option C. So option C will be the correct one. The first one will be like this one. The CH3 whole thrice C dot 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 Br. This is the first transition state, weakening of the bromine bond, and after bromine is carbocation will form, then that will be your intermediate. Now if I talk about second transition state, so this will be like in carbocation, this ETOH is attached. So this will be looking like this one. Me3C, and here you can see you are having O, ET, here H, and here delta plus is coming, and here delta plus is coming. So this is your second transition state. Now in the third one, what will happen? To this only deprotonation will happen. So third one you will be getting like this one, Me3C, O, ET, delta plus, and delta plus for hydrogen. So after this transition state, hydrogen will be removed and you get Me3C OTL as final product. In second transition state, what is happening? This ETOH is getting attached to carbocation. So that's why delta plus, when it will attach fully, so oxygen will be having positive charge and carbon will be having no charge. And this is the first step. Is understood or not? Or I can tell in next class also if you are not getting right now. Any doubt in this? See, in option A also it is like SN1, but here says hydrogen is not there, so deprotonation will not happen. So it will be having only 2 steps. One, first is carbocation will be formed, and in second step, this C6H5 whole thrice P will attach. Okay, so I can write also this one. So for option A, you are having Me3Cl. That will give you Me3C plus. So this is the first intermediate. Now with this first intermediate, this PPH3 that is having lone pair, that will combine and you will get Me3C bonded with PPH3 plus. So you can see only 2 intermediate are formed. Only 2 hump you can have. But for 3M, it only matches with C option. So you can go through this question. If you will have doubt, I will again explain in next class since there is no time left. So anybody want to say something so I can wrap up now? And I will upload the assignment. So actually I have increased the number of question in assignment because I'm getting only 2-hour class. So maximum question that I can solve that I'm solving. So I have increased like 25 questions will be present in assignment. And please try to do all the question of assignment. Then only your comprehensive chapter will be covered. So if anybody is having something to say, you can say, otherwise you can leave.
Thank you, sir.
Thank you, sir.
Bye, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Increase due date in assignment.
Yes, what you're telling?
Can you increase due date in assignments?
So for this one, it will be 13 May. Because up to 13 May, you are having vacation.
Yeah, so no.
So previous assignment, I cannot extend because that has already gone. For today, I have given, I think. I do not remember which date I have given.
Sir.
So have you
No,
not submitted
not
the
yet,
previous
sir.
one? So I will see, means if there will be chance to increase, then I will increase it. Otherwise, I have uploaded the PDF that you can solve by yourself. That there is no issue. You will not get only the chance to
Okay,
upload.
sir. Okay.
Okay.
Fine, sir.
Okay.